Okay, I've got another first-person radio video for you guys. In the last video, we built one of these antenna transformers for it's a 49-to-1 transformer for an end-fed half-wave. And now I'm going to show you guys how to measure the efficiency of this guy to see how much of your power is actually going to make it into the antenna and how much is going to be lost. You're going to lose a little bit, but you can measure that and make sure that it's not too extreme, which can help confirm that you built it right. So the tools we're going to use for this, you could use really high-tech tools, but at a basic level, you're going to need a little power meter. This is a SWR meter, standing wave ratio. I can go into that later. But this left side here is power output, and then the right side is reflected power. If my antenna is tuned properly, I won't have any or very little reflected power, and then I can just read off my power output. In the back of this is what's called a dummy load. And all this does is absorb my radio signal and dissipate it as heat. So normally if I was plugged into an antenna, I would see my power out to the antenna, but I don't want to actually transmit. I'm just using this to act like a fake antenna and absorb my signal instead of transmitting. And I have my radio that I'm going to use to put power through this guy, and I'm going to measure how much of it is lost. Now, an interesting thing about antenna tuners in general, any kind of antenna tuner, the technical term is going to be an impedance matching circuit, is that they're kind of reversible. So if I have 50 ohms come in hit this way, and on the other side, the transformation makes it about 3,500 ohms, then I can have 3,500 ohms come in this way and then 50 come back out that way. So what you can do is you can build two of them. I built this one a long time ago. I've been using it for quite a while. It's the same design. The capacitors are just, like a different model, but it's basically the exact same thing. So I can put these back to back and connect them together. And then I have 50 come in, 3,500 go out, then 3,500 come in and 50 go out, and then plug it back into this. And it's like this is just a little piece of coax cable. But I can measure how much power is absorbed by the two of these. And then I can calculate from that how much power is absorbed by one of them because they're the same. So it should be the same percentage of power. It's not quite as straightforward as just saying, oh, I put 5 watts in and got 4 watts out. So half a watt on each, and that means they lost, 10%? Not quite. You have to use decibels because it's about percentage of power going in and percentage of power out. So say I put 10 watts into this one and it ate up half of the power. I'd get 5 watts out. And then 5 watts into this guy, and he also eats up half the power. He'd have 2.5 watts out. So I'd go from 10 watts to 2.5 watts. And it's not, the math doesn't work out if you just divide that by 2. You have to use decibels. I'll show you how to do that. There's a little calculator online we're going to use. So let's get started. I'm going to connect the positive terminal to the positive terminal and the negative to the negative. Let me just... I just got a couple scrap pieces of wire I'm using. There we go. And then I've got an extra piece of coax cable to go from the other tuner to the dummy load. All right. There we go. So they're wired together now. So here's my radio. By the way, the efficiency of your antenna tuner can be different for different frequencies. So you can do this test on every band you want to transmit on, and that'll give you an idea if your efficiency drops off. I've had some of these that the efficiency is great on the lower bands but poor on the high bands, or great on the high bands and poor on the low bands. So all right, let me plug my external battery in. And I'm just going to do 7.2 megahertz, which is the 40 meter band. So we're just going to test it with that for today. So the first thing you do is you plug your radio directly into your power meter. And I set this to FM mode right now. I would never actually use FM mode to make a contact, but the good thing about FM is it puts out full rated power. As soon as you hit the push to talk, you don't have to whistle into it or anything like you would with AM or single sideband. All right, so how much are we getting out of here? We are getting almost exactly 4 watts. Yeah, 4 watts. Maybe like 4.1 or 4.2. Yeah. Okay, so that's our input is 4 watts. Now let's plug these guys in. So I just plug, oh, all right, my little wing nut was touching the outside here, which is fine because this wing nut is ground and that should be grounded, but you know, not ideal, I guess. Startled me. And then I'm going to plug my cable from this guy into my power meter. And signal is going to go into here, transformed up in impedance, then transformed back down, and then back into here. And now we end up with 2 watts. Okay, so we lost half of our power, right? Which sounds really bad, but some amount of loss is inevitable. You get loss from coaxial cable, right? And really, the exact amount of power you put out isn't really that important as long as it's reasonably close to what you expect. So let's plug this in here. I've got a little decibel calculator here. I happen to know the answer for this one because it's exactly half, but we'll just calculate it, right? So power number 1 was 4 watts. Power number 2 was 2 watts. And it's going to tell me that I am minus 3 decibels, right? So this took 1.5, this took 1.5, 3 decibels total. Now if I go over to this other calculator, this one here, and let's say I put in 5 watts, oh, 4 watts. We're putting out 4 watts. And then I lose 1.5 decibels. That shows me that I would end up with 2.83 watts output. I lose 30% of my signal with 1.5 decibels. Now, if I stack that together, I don't lose 60% of my signal, I lose 50% because, you know, your signal's a little bit smaller when it goes into the second one, right? So you can see that you can't just divide it by 2 and say that you lose 1/4 of your signal. You lose a little bit more. You lose 30% instead of 25. But we've calculated it. These guys have 1.5 decibels of loss. So let's look at a different one. I've got a larger one here. This guy is the exact same design, but it uses a much bigger inductor. These are 2 of those full-size FT240-43 toroids that were recommended in the design. This uses 1, this one uses 2. Other than that, it's the same exact design. Let's see how this one does. This one I know is more efficient. The larger the core in these inductors, or the larger the core in these transformers, the more efficient they tend to be. But again, you're kind of splitting hairs at a certain point. But let's test this real quick. All right. Now, these aren't the same anymore. So if I only had these 2, I couldn't figure out how much each lost because they're going to be different. But let's figure this out. And I need to connect this one back into my power meter. All right. Oops. All right, what do we got? Well, that's not right. Ah, okay. Well, look what I did here. I went negative to positive, positive to negative because I'm an idiot. My bad. Mistakes happen, and I am basically doing this live, so I hope you understand. If you're not satisfied, I can give you your money back. All right, here we go. There we go. All right. We are getting... Okay, it's a little bit more than 2 watts. It's a little bit more than the other one, but not by a lot. I'm not going to bother plugging that in. It's basically the same. All right, so now there are other methods of tuning your antenna other than one of these transformers. I just like these because I don't have to fiddle with any dials. You can also use an L-match transformer, which is what this is. They call it an L-match because of the, if you diagram what this circuit is doing out on paper, it's an L shape, the components that are put in. But we can cover that later. I'm just going to get this guy screwed in. The advantage of an L-match is that they're very efficient, and you can tune pretty much anything with them, assuming they have high enough component values. Like if you have, they use inductors and capacitors to do impedance transformation. And if you have enough available, right, like if you had an unlimited amount of inductance and an unlimited amount of capacitance, you could literally just tune anything. But you never do, right? You have a limited amount of inductance and capacitance. Most built-in tuners for radios can only do like a small amount of transformation. The other disadvantage is you have to fiddle with them. You have to like flip all the switches and levers and turn the dials to tune a particular antenna. Whereas with these, if you get the right length of wire, it just does the transformation for you just fine. So I already fiddled with this off screen. So how much power do we get out here? We get out, well, my SWR is a little off. Let me tweak it. There. There. All right, I had to tune it again. Must have bumped the capacitor. So now we get, that looks like just under 3, so like 2.75 watts. So let's see if we go from, oh, look at that. So let's say 4 to 2.75. That's 1.63 decibels. And keep in mind, this one is 1.5 of those. So this one's like 0.1 decibels, right? So this one is extremely efficient. There's almost no power lost in this guy. But it's a pain in the ass to use because you have to plug your antenna in and then you key it and then you flip a couple switches and then you key it and you flip a couple switches and then you turn the dial and then you key it again. It's much more of a pain to get right. So that's why I use these guys. And one last thing about decibels. On your radio here, you've got an S meter, right? An S meter on the bottom that shows you the power of your received signals. Each one of those little tick marks on that S meter is something like 9 decibels, right? 3 decibels cuts your power in half. So that's cutting it in half 3 separate times for each one of those little tick marks. And that's the difference between someone saying, oh, you're 5'9", and someone saying, oh, you're 5'8". That's not actually a lot of difference in received signal strength. Power helps a little bit, but unless you're making huge jumps in the amount of power you're putting out, like unless you're like tripling or quadrupling the power you're putting out, it's not that significant of a difference. Maybe doubling is the minimum amount of a power difference I would worry about. If it's cutting your power in half, that's significant. If it's cutting your power by 10 or 20%, don't worry about it. And even then, cutting your power in half or doubling it does make a little bit of a difference, but not as much as you might think. Which is why with a little 20 watt or 50 watt radio, you're really not that undergunned relative to guys pushing, 300 watts or 500 watts. They've got an advantage, but it's not completely overwhelming. So I hope that made sense. You can get transformers and tuners of all different kinds. I've built the same design in a bunch of different sizes. And the smaller ones like this guy tend to be less efficient. By the way, this is the K6 ARK kit for a 49-to-1 transformer. It's basically the same design as these, but he makes them extremely small, and he has a little printed circuit board in there that holds the capacitor and everything on the other end of a BNC connector. It is extremely convenient, but this is like 5 watts, maybe 10. So I can't put them on my big radio. It would overheat this guy and probably break something. But they're really nice if you're just putting out 5 watts. I do about this size. So yeah, I hope it was useful. And our next video, I will be showing you how to trim your antenna to resonance. So I will take this transformer that we built. I've got lengths of wire cut. I will get them in the tree, and I will show you how to measure your SWR and then trim your antenna so it's resonant at the exact frequency you want. Every bit of wire is a little bit different. If you use a different kind of wire, your antenna needs to be slightly longer or shorter than it might say just based on the formulas. So we will go do that in the field. And then once you have built this guy, trimmed your antenna, and you've bought your radio and your battery, you are ready to operate. I'll do another segment on batteries and power consumption and how to figure out how big of a battery you need, how much power your radio is using, and kind of considerations there as well. So those are the future planned videos. But I hope this was helpful, and I will see you next time.